So again, algebraically, this seems to be a theme. We're doing a lot of these algebraically. We're always going to switch x and y. And all they want you to do is switch x and y and then figure out if they are matches for each other. So for I, if I took y equals 3x minus 6 and I switched the x and the y, then solve for y, add 6 to both sides, divided by 3. Does it match perfectly with the other one? Close. But they have a minus sign, and we have a plus sign. So are these inverses? No. For the second one, switch x and y. Ooh, they already restricted the domain. Okay, so this one might be helpful to think of the graph. If I think of the original graph, negative x squared plus 3, I'll do that one here in blue. That would be a parabola that got flipped down and then moved up 3. So the vertex would be right here. But I'm only looking at the part of the parabola where x is bigger than 0. So algebraically, when I go to solve this one, I switch the x and the y. I subtract the 3 on both sides, multiply everything by a negative. Negative x plus 3 equals y squared, and square root both sides. Everybody agree that negative x plus 3 is the same as 3 minus x? Just because that's how it was written here. So I would get square root plus or minus 3 minus x. Now the question is, will that be the positive one or the negative one? Here's our graph. This point I know is going to go through the same. This one, 0, 3, will now be at 3, 0. Since I know this point is the same and it goes through this one, it has to look that way. So are we correct in having the positive one? Yes. And so we did in part 2 already verify it graphically. In part A, if you graph both of these, okay, we have to graph a lot of lines this year. Next year when you're in the IB course, again, lots of lines you have to graph. So y equals 3x minus 6. Just a quick review, you know y equals mx plus b. Again, I'll graph this one, first one in blue. Minus 6 is your y-intercept. Three is your slope. So you'd go up 3 over 1, up 3 over 1. Here's our first line. For our second one, which we have here like this, again, this idea of multiplying by a third might be more helpful because you would get 1/3 x plus 2. And for that one, we'd have a y-intercept of 2. Up 1 over 3. And if I had perfect graph paper, which I didn't use in this case, but if I would look at y equals x, it's not a perfect reflection over top. It's close, but not perfect. Did I graph? Yeah, I graphed the first one right. So as far as questions for this one, I have 7 and 8. Those are straightforward. 11 and 13. As I said about the quizzes and the tests, I'll put a little asterisk beside them. Those ones are just a little bit different. So there's a good opportunity for you to say, do I have those skills that I can approach a question that's a little bit different and still be able to do it? And if you have trouble with that, of course, come in for extra help. But that's a good way of problem solving through this.